Welcome to lesson 7.9, diagonals of quadrilaterals. So basically, this whole lesson is going to come down to a couple key review ideas and summarizing some key properties into the hierarchy of quadrilaterals, which you will see later in the notes summarized here. So, to begin with, we are going to briefly review in these kind of 3 paragraphs some of the key theorems and ideas related to properties of different quadrilaterals. So, the top bullet point here has to deal with the kite diagonal theorem, which states that the symmetry diagonal of a kite is the perpendicular bisector, so splits the other diagonal at 90 degrees. So it's the perpendicular bisector of the other diagonal. This means that for a rhombus, each diagonal is the perpendicular bisector of each other, which you can see in the diagram over here at the right. That means also every square must have this property because every square is a rhombus. So in summary, kites, rhombuses, and squares each have a diagonal that is a perpendicular bisector of the other diagonal. And for both a rhombus and a square, it happens to be for both. In a kite, it might be for both or one. Then we have the properties of parallelograms theorem that we looked at previously with those 4 different sufficient properties. But in this case, we're just going to look at the diagonals. So the properties of parallelograms theorem states that the diagonals of a parallelogram intersect at their midpoints, meaning they bisect each other. So you can see that again in the diagram over here, bisecting each other, meaning it splits each diagonal into 2 congruent parts. So because the rhombus, the rectangle, and the square are all below and connected to a parallelogram in the hierarchy, this property is true for all those quadrilaterals as well. So our summary here would be that the diagonals of parallelograms, rhombuses, rectangles, and squares bisect each other. And then our last kind of summary bullet point here is looking at an isosceles trapezoid. So in an isosceles trapezoid, we know the diagonals are congruent. Then we also know, so furthermore, the diagonals are split into corresponding congruent parts. This rule applies to rectangles and squares as well, due to the fact that they are below an isosceles trapezoid in the hierarchy. So our summary here is that in isosceles trapezoids, rectangles and squares, corresponding parts of the diagonals are congruent, but also we know, if we again think about it up here, that basic idea that the diagonals are also just in general congruent. So corresponding parts and the whole diagonals are congruent. So looking at those properties and applying them, example 1 asks us to draw a quadrilateral with perpendicular diagonals that is not a kite or trapezoid. So we could refer to our hierarchy, and we would want something with perpendicular diagonals, but it could not be, according to this, a kite or trapezoid. So one diagonal is at least the perpendicular bisector of the other. Can't use a kite. So in this case, though, they didn't say anything about a rhombus or a square. So rhombus and squares also have that property because they're below a kite. So we could use a rhombus or a square in this case. And again, that comes from the idea up here of this perpendicular diagonals. In part 2, draw a quadrilateral with congruent diagonals that is neither a kite nor a trapezoid. So we need congruent diagonals. So again, in this case, both parts of diagonals are congruent. That applies to our isosceles trapezoids, our rectangles, and our squares. So in this case, we could draw a rectangle or a square. So again, those beginning paragraphs are summarized here in this hierarchy. Anything that's below and connected to a section above it, those properties apply each time you move down. So again, the properties of a parallelogram and kite would apply to a rhombus. Properties of a parallelogram and trapezoid apply to a rectangle, but a rectangle is not attached to a kite, so the kite properties do not directly apply to a rectangle. And then the square would have the properties of a rectangle, a rhombus, a kite, a parallelogram, and an isosceles trapezoid, because that factors back to all of those through its connections. So we're going to use the hierarchy to give the most general name for the quadrilateral based on the images here. So if we look at this first image, what we know is we have 4 congruent parts, and that tells me that these diagonals bisect each other as well as creates those corresponding parts. So in this case, the diagonals are congruent, so that applies to an isosceles trapezoid, and the diagonals bisect each other, so that applies to a parallelogram. So if we have the properties of an isosceles trapezoid and a parallelogram, our general name for that quadrilateral would be a rectangle. Then, looking at our second image here, we know that the diagonals are split into 2 congruent parts. So that tells me the diagonals bisect each other. So if simply all we know are diagonals bisect each other, our most general name for something where the diagonals bisect each other would be a parallelogram. Our bottom left here, we have a 90-degree angle, so we know the perpendicular bisector. And then we also know that it was split there, so that's the bisector piece into congruence, 90-degree being the perpendicular. So all we know are perpendicular bisector. So if one diagonal is the perpendicular bisector of the other, then we know that it gives us the kite. Now, the other thing that we could call the kite, which you'll notice here, what's different between the kite and the rhombus is in the kite, this segment and this segment, we do not know were necessarily congruent to each other because this has 2 dashes, this has 3. So here and here were different lengths, but here and here were the same. So we had the one diagonal being the perpendicular bisector. In this example, what makes it a rhombus is this part's congruent to that, and this part's congruent to that, plus a 90-degree. So in this, we have the diagonals bisecting each other, and we have the one diagonal as a perpendicular bisector. So we have the kite and the parallelogram, which would give us the general shape of a rhombus.